Welcome to IronHand Tech Channel. Today we will explore an exciting journey, the journey of recycling old car tires. Did you know that every year the world produces about 1.7 billion tires, and only about 35% of them are recycled? Why is tire recycling so important, and how does this process work? Let's find out right away. In 1846, Robert William Thomson was granted a patent for the invention of pneumatic tires. However, it was not until 1880 that John Boyd Dunlop really perfected and put pneumatic tires into widespread use. He realized that pumping air into the rubber helped reduce vibration and increase the smoothness of the car. Since then, billions of tires have been produced in the world. Although they are getting more and more durable, the car tire landfills are still getting bigger, requiring them to be disposed of. Few people expect that these discarded tires can be called black gold. These old tires are collected from maintenance centers, scrap yards, and other collection points. This is the first and important step to prepare for the next recycling steps. Burying tires has never been a perfect solution. Rainwater seeping through tire landfills will dissolve toxic substances, flow into groundwater, polluting water sources. Burning tires is the same. A large amount of toxic gases such as dioxin, furan, fine dust particles seriously affect human health and the environment. Therefore, tire recycling brings hope to create new materials, but they also help clean the environment, avoid the spread of disease and potential risks of fire and explosion. At the plant, the tires are cleaned to remove dirt, stones, and other impurities. This prepares the tires for the crushing process, ensuring that no impurities will affect the quality of the recycled rubber. Workers then tear off the steel cords in the tires. This is done by a special machine that takes 20 seconds to remove the steel cords from the tires. These steel cords can be further recycled and used in the construction and other industries. The tires are then fed onto a conveyor belt into a grinder, where sharp blades do their job, breaking the tires into tiny rubber pieces. And this giant drum breaks them into even smaller pieces. The machine also has a magnet to attract any metal fragments that remain after the grinding process. This process transforms the tires from a hard state into smaller, easier to handle pieces. After grinding, the rubber flakes are filtered to remove any remaining impurities, usually reinforcing fibers made of nylon or other synthetic fibers. This is an important step to ensure that the recycled rubber is of high quality, ready for further reuse. The rubber flakes continue to pass through a vibrating machine to separate the powders of different sizes. The crushed rubber is fed into a mixer, where it is mixed with a polyurethane binder. To get the final product, the desired color, the colored mixture is put into a mold with the undyed rubber mixture, pressed by hand, and then sent to a hydraulic press. Here the bricks are pressed to the appropriate level. Finally, they are placed in a drying oven for about 8 hours. Now the bricks are ready to be used for paving playgrounds, parks, sidewalks. In most countries, recycling old tires is a complicated and expensive business. In the United States, about 81%, equivalent to 225 million tires, are recycled each year, while in Europe, the rate is even higher, reaching 96%, but there are still many tires out there that are not recycled. The complex structure and chemical resistance of rubber make it difficult to separate and recycle the components. However, this process is being accelerated because people see its undeniable benefits. Today, cars are still operating on the streets. Each car rolling on the road carries a story. And the story of old tires, when recycled, becomes a new chapter full of meaning. Whether you drive to work every day or take a road trip on your day off, after a long enough period of use, your tires will start to show signs of wear. Once your tires reach a tread depth of 1.6 meters, you need to replace them to ensure maximum safety on the road and to comply with the law. This replacement of car tires results in about 30 million tons of tires being replaced and potentially thrown away every year worldwide. But now there is a solution to this problem. Car tires will be recycled into oil at a special plant. Let's find out about this process today. At the service centers, old car tires are collected and then sent to recycling plants. In Korea, there are about 30 collectors who collect and supply scrap tires to recycling plants. The tires are back on the road, but with a completely different mission. At the factory, workers tear out the steel wires from tires. This is done by a special machine that takes 20 seconds to process each tire. Its iron fingers hook into the tire and pull with great force through a hydraulic system to extract the steel wires from the car tire. The steel used to make the steel cords in automobile tires are high tensile steels with good elasticity and high wear resistance. These steel cords will be compacted and can be further recycled for use in the construction industry and other industries. At the plant, the tires are cleaned to remove dirt, rocks, and other impurities. They are then sent to a crusher on a conveyor belt. Here, the crusher chews up the tires, turning them into tiny pieces. The rubber pieces continue to be removed of impurities through the vibrating machine system before reaching the next processing stage. The tire pieces are transported to the pyrolysis area. The purpose of this is to decompose the chemical bonds in the rubber to create simpler products, mainly oil. The rubber is fed into a reactor where the temperature is 50 to 500 degrees Celsius and there is no oxygen. Here, the large rubber molecules will be broken down into smaller molecules such as hydrocarbons. Then, these hydrocarbons will be converted into vapor and gas, including oil gas and some solids, and oil is the main product in this stage. The finished oil then goes through a filtration and refining process to improve quality and remove harmful compounds. Recycled rubber oil products, FOR, are highly applicable, low cost, high calorific value, and more environmentally friendly. In most countries, recycling old tires is a complicated and expensive affair. In the United States, about 81%, equivalent to 225 million tires, are recycled each year. While in Europe, the rate is even higher, reaching 96%. However, there are still a lot of tires out there that are not recycled. Tire recycling is a great example of a circular economy. By reusing resources, we reduce our dependence on fossil fuels and create a more sustainable future. This is not only a solution to an environmental problem, but also a new economic opportunity. Electric vehicles are gradually becoming a popular means of transportation in the world today, with an environmentally friendly image and low carbon emissions compared to gasoline and diesel vehicles. It is expected that there will be around 145 million electric vehicles on the road by 2030, along with more than 12 million tons of lithium-ion batteries that will be collected between now and 2030. Most of the batteries in electric cars and motorbikes today are made from lithium-ion, a material that is highly conductive, but also highly flammable and extremely toxic due to the presence of compounds such as cobalt, nickel, and lithium. Therefore, they cannot be buried, and these batteries are still full of materials that are as good as new. One of the biggest sources of CO2 from electric vehicles is the mining and manufacturing of battery packs. Mining lithium is not a CO2-friendly activity, so there will come a point where recycling batteries for the metals needed will be a key factor in helping electric vehicles become carbon neutral. Significant shortages of battery materials are emerging in the near future for materials such as lithium, nickel, cobalt, and copper. Battery cells are mined from raw materials that often travel more than 20,000 nautical miles from the mine to the car manufacturer, which is a fragile supply chain. Therefore, battery recycling also plays an important role in the sustainability of the EV industry itself. That's why today we will explore a special process for recycling EV batteries. Let's get started. The good news is that the metals and the critical materials inside the battery are highly recyclable. About 95%, 98% of the critical materials in the battery, such as nickel, cobalt, copper, can be recovered. After collecting old batteries from different sources, we will follow these batteries to the recycling plant to explore a complex and high-tech process. After being sorted and disassembled, the batteries are fed into a crusher by conveyor belt to be crushed. After this process, we have a complex mixture containing many types of materials, including precious metals such as lithium, cobalt, nickel. This mixture is the precursor to black mass. The crushed battery mixture is immersed in special chemical solutions, dilute acids. The metals in the battery will react with the solution and turn into ions. By adjusting the pH of the solution or adding precipitants, the metal ions will precipitate into insoluble black compounds, which are called black mass. In addition, after this process, we can also recover the remaining materials such as aluminum, copper, plastic, and other precious metals. After this process, the black mass will be refined to recover components such as plus lithium, cobalt, nickel, which are then used to produce new electric vehicle batteries. Copper, used in the production of electrical wires, electronic components. Aluminum, used in the production of battery casings, other aluminum products. Currently, this is the most advanced recycling process, minimizing pollution. By extracting many valuable components from old batteries, this process not only protects the environment, but also contributes to creating a circular economy in the electric vehicle industry. Despite its important role, the current recycling rate of electric vehicle batteries is quite low. In Australia, only about 2 to 3% of batteries are sent for recycling, and in the European Union and the United States, it is less than 5%. To increase this rate, it is necessary and urgent to research modern technologies and raise people's awareness of recycling electric vehicle batteries. Let's join hands to protect the environment and develop the electric vehicle industry sustainably. We are at a local recycling plant where aluminum cans are collected from many places and brought here to be prepared for recycling. I admire these workers. They work in a very polluted environment, lacking protective equipment. You can see smoke and dust everywhere. I can smell the burning smell when making this video. First, the aluminum cans are flattened, sorted, and melted at high temperatures. Aluminum is an ideal material for beverage packaging because it is lightweight, corrosion-resistant, easy to produce, and of course, easy to recycle. Aluminum also does not react with the ingredients in soft drinks, ensuring safety for consumers. They can be designed in many different shapes and colors to attract consumers. The temperature of these furnaces can reach thousands of degrees. You can see workers working very close to the furnace without any protective gear. It's amazing. Do you know what this white powder is? It is magnesium, which plays a very important role in this process. Magnesium has the ability to combine with some impurities in the molten aluminum, forming compounds with lower density. These compounds will float to the surface and are easily removed, helping to clean the aluminum. In addition, they purify the structure of aluminum, increase the ductility and durability of aluminum, and its corrosion resistance. People also add sand or soil to reduce the temperature of the mixture, but this does not seem to work. Sand has a very high melting point, much higher than aluminum. Adding sand will reduce the temperature of aluminum, affecting the flowability and quality of the final product. Impurities are removed before the molten aluminum is poured into the casting mold. Molten aluminum is poured into rectangular molds. The aluminum sheets are heated and flattened. These large drums rotate at high speed, stomping on the aluminum bars to flatten them. And once again, the aluminum sheets were tortured. They were pressed even thinner and then cut into pieces of suitable size. And now they were round. Under the pressure of the hydraulic press, the aluminum pots began to take shape. This guy's doing the grinding process. Obviously, it makes these pots look nicer. Did you know that recycling aluminum reduces carbon dioxide emissions by 95% compared to producing virgin aluminum? And recycling 1 ton of aluminum can save 15 tons of bauxite ore, 10,000 kilohours of electricity, and 35,000 liters of water. Of course, with the process at this factory, that number may not be accurate anymore, but it's certainly better than burying these aluminum cans underground, right? Now that our aluminum cans look like pressure cookers, they are cleaned with specialized cleaning solutions, usually NaOH dye or HCl. For recycled aluminum, people need a strong cleaning method because aluminum contains many impurities. I'm pretty sure if you've watched this far in the video, you'll see that these people are amazing, they're skilled, they're passionate, they're persistent, and they're hardworking. You also find your work day-to-day much less tiring. Personally, I both admire and feel quite worried about them. Their health is likely to be affected when working long-term in these conditions. The lids are also made from recycled aluminum, and at this factory they produce hundreds of pressure cookers every day and employ dozens of people. For me, there is nothing better than protecting the environment while creating jobs and income for others. Now, every time you drink Coca-Cola, throw the can in the trash because it can be recycled into pressure cookers like this. Have you ever wondered where the boxes go after being taken care of? How do people handle them? Join us in exploring the magical journey of a ring box from being discarded until becoming a completely new product in today's video. Let's get started. Cardboard boxes are considered an environmentally friendly product. However, they are made from wood harvested from industrial tree growing areas, and like many other materials, they need to be disposed of after use. Burning or burying cardboard in landfills is not a perfect form of disposal, as buried cardboard releases large amounts of methane, a greenhouse gas that is 25 times more potent than carbon dioxide. So recycling cardboard is a better option, and surprisingly, cardboard can be recycled more than 20 times before the fibers become so weak that they are washed away during the recycling process. For comparison, on average, it takes about 4.4 tons of wood to produce each ton of paper, but only 1.4 tons of used paper can produce 1 ton of recycled paper. Thus, each ton of recycled paper will help save 24 natural forest trees, limit an amount of CO2 equivalent to the emissions of a car in 6 weeks. Today, a process called the carton recycling value chain is in place. Cartons are collected through residential collection programs, along with other recyclable materials. They are transported to a materials recovery facility where they are sorted and baled. From there, they are sent to a paper mill or to a facility that produces sustainable building materials. According to data from the Paper Bag website, European countries are the world leaders in the field of recycled paper. The paper recycling rate in Europe is 71.5%, while in Korea, Thailand, and Japan, the paper recycling rate ranges from 65% to 75%. Join us on a visit to a recycling plant to discover the secret behind the regeneration of cardboard boxes. Once sorted, the cartons are fed via a conveyor belt into a shredder, essentially a giant blender. Here, water and blades gobble them up and crush them into tiny pieces, much like the shredded paper we see today. Once crushed, the scraps are fed into a large water tank where they are mixed with water and special chemicals to remove the ink and release the fibers in the paper. The fibers in the paper are broken down during this process and become suspended in the water to form a slurry. To ensure the quality of the pulp, the paper scraps are passed through a filter. This centrifuge removes foreign matter such as tape or glue. Plastics and metals are also removed during this process. Plastics float on top while metals sink to the bottom. To make the recycling process easier, today, right from the production stage, people have effective measures such as choosing the right ratio of wood fiber, using environmentally friendly adhesives, minimizing non-recycled components, and using environmentally friendly printing inks. Now that we have the pulp, it is pumped through the pipes and sent to the forming machine. At the forming machine, the cleaned pulp is spread out to dry on flat conveyor belts and heated cylinders. As the pulp dries, the excess water is also squeezed out. This process effectively forms long rolls of solid sheets from the fibers. These sheets are pressed through rollers. At this point, the thickness of the paper is determined, which will range from 100 to 210 journalism. This process produces large rolls of brown paper, 2.5 mm wide, which can weigh up to 10 tons. Finally, the large sheet is cut into smaller sheets of paper of different sizes, depending on the intended use. These sheets of paper will be used to produce many other useful products, such as paper boxes, toilet paper, tissues, helping us save resources and protect the environment. Together, we have explored the magical journey of a cardboard box, from being thrown away to becoming a useful new product. Recycling cardboard not only helps protect the environment, but also contributes to building a sustainable future. The world produces over 2 billion tons of trash every year, enough to fill over 800,000 Olympic-sized lakes, and about 1/3 of that is either disposed of or openly burned. Massive landfills are still being fed every day, and by 2050, the amount of waste generated annually is expected to increase to 3.4 billion tons. As waste piles up, without landfills, we will live with the waste we ourselves create. So what is the solution to this problem? In fact, the waste management process includes collection, treatment, and disposal. After the waste is collected, there are three main ways to handle it: burning it in an incinerator, using a landfill, or dumping it openly without any treatment. While 33% of global waste is dumped directly in open landfills, governments increasingly recognize that these sites are harmful to the environment and can be vectors of disease. The problem is that there is a need for sustainable options for waste management. A number of patents have been filed for copyright registration since the early 1980s for burning waste to generate electricity. Around the early 2000s, trash incinerators and large trash treatment centers were born and developed with large amounts of burned trash to produce superheated steam to turn turbines to produce electricity. So how does waste incineration technology work? Let's find out together in this video. First, large trucks carrying garbage are collected from households, industrial and commercial areas and brought to treatment plants. Collecting and classifying waste is an important issue for effective waste treatment. The common characteristic of waste is its diverse nature, with many types from metal, pieces of porcelain, organic waste from food, paper, nylon and rubber products, plastic, and sometimes even soil and rock. Waste classified as burnable includes paper, nylon, rubber, etc. The compostable organic form includes vegetable, tuber, fruit and food scraps. The non-burnable inert form includes rocks, ceramics, construction materials, etc. To be able to classify effectively, this requires a classification system right from the source, from each household and business. Huge cranes take trash from the bunker into the incinerator. The temperature in the oven is about 850–1000 degrees Celsius. The heat emitted from the combustion process is used to boil water in pipes placed in the furnace. Boiling water creates high-pressure steam. Steam under high pressure is directed to the turbine. When in contact with the turbine blades, the steam will exert a large force on the blades, causing them to rotate at high speed. The turbine shaft is connected to a drive shaft. The rotation of the turbine will drive this shaft. The drive shaft is connected to the generator. As the shaft rotates, the coils in the generator cut through the magnetic field, creating an induced current. Electricity produced from the generator will be transmitted through power lines to supply the plant's own operations and into the national grid. Exhaust gases from the combustion process are passed through a treatment system before being released into the environment. The incineration process reduces the volume of waste by 90%, which saves space for landfills. Metals and non-ferrous metals will be recovered from the ash. After that, the ash and slag are buried in safe landfills. The method of burning trash to generate electricity is an advanced method, helping to reduce the amount of waste that has to be buried and minimize environmental pollution. Take advantage of the potential energy source in waste to produce electricity, thereby minimizing dependence on traditional energy sources such as oil and coal. Costs from electricity sales are used to invest in waste treatment systems, partly contributing to creating a circular economy. However, the investment cost for this technology is very large. It is difficult for developing countries to invest money in such a technology. This technology also requires classifying waste to serve good purposes. Only some types of flammable waste can be burned to create energy. Even though it has been treated, there are still exhaust gases released during the combustion process. Waste-to-electricity technology is a promising solution, contributing to environmental protection and ensuring energy for the future. However, to develop this technology sustainably, we need appropriate policies and community cooperation, especially waste classification at source. Copper is present in most of the devices we use every day, from electrical wires, computers, motors. Did you know copper is one of the few materials that can be recycled many times without losing performance? There is also no difference in the quality of recycled and mined copper, so they can be used interchangeably. In addition to environmental benefits, recycling complex copper scrap, such as e-waste, promotes the recovery of many other metals such as gold, silver, nickel, tin, lead, and zinc. Each year, about 8.7 million tons of scrap copper are recovered and put into the recycling process. Statistics show that recycling 1 ton of copper can save up to 85% of energy compared to producing 1 ton of new copper. So how does the process at the copper recycling plant work? Let's find out in today's video. It all starts with collection. We have thousands of old engine compressors at this recycling facility. The motor compressor will first be disassembled to recover scrap copper. In this factory, they do this method completely manually. First, workers used a gas welding machine to cut the compressor casing. This flame created by oxygen and acetylene gas has a temperature of thousands of degrees Celsius, helping it easily cut through the thick iron shell of the air compressor. Using acetylene gas for cutting requires workers to have experience and skills. This is also very unsafe. In small and rudimentary establishments like this, ensuring safety is very sketchy. Is probably the thing that needs the most attention and improvement. After separating the air compressor housing, we have the motors here. Now it's time to recover the copper coils from these motors. This guy really has very good skills. With just one pair of scissors, he skillfully separated the copper coils from the motor. Not only that, I think the skin on his hands is also very special. It helps him not get injured when doing this job. It's unbelievable. The copper coils are then melted in large furnaces. This is a fuel furnace. It uses gas to generate heat. Copper scrap is placed in a furnace and heated directly by a flame. The temperature in this furnace is 1,085 degrees Celsius. At this temperature, any remaining impurities are burned away, leaving behind pure copper. The liquid copper is then poured into molds to form large copper bars. Before pouring liquid copper, mold release agent is applied to the mold. In this factory, people use oil as mold release agent. When the copper cools and hardens, the mold coating helps prevent the copper from sticking tightly to the mold, making the mold release process easier and avoiding product damage. After a few minutes, people split the mold to collect these red-hot copper bars, which are cooled with water before being reused for other purposes. Copper is one of the world's most recycled metals, and its recycling contributes to a step towards a more circular economy. Over the past decade, about 32% of annual copper use came from recycled sources. So there we have it, a wonderful journey into copper recycling. From collection to creating new products, recycling copper is a win for both the environment and the economy. In our developed world, we can easily take soap for granted. According to Accor, a hotel chain in Scandic, hotel guests only use 15% of the soap, shampoo, and conditioner found in their rooms, with the majority being discarded, some even unused. Approximately 26 million bars of soap are thrown away in the US, leading to an annual waste of 1 billion bars of soap. Considering that the US accounts for less than 30% of the 157 million hotel rooms worldwide, the global loss each year is staggering. Soap is made from a chain of molecules with two main halves. One end of the chain is hydrophobic, meaning it repels water, and lipophilic, meaning it is attracted to fats. The other end of the molecule is exactly the opposite, hydrophilic and repels fats. Put these two halves together, and you have one of humanity's greatest inventions: soap. Most people have the impression that soap sanitizes your hands by killing bacteria and viruses on your skin. However, this isn't entirely true. Germs and dirt cling to the oils and fats on your hands. Soap molecules then attach themselves to these oils and fats. And when you rinse your hands under water, they cling to the water molecules, pulling the oils off your skin and taking any bacteria they contain with them. In hotels, restaurants, and even in every household, thousands of tons of soap are discarded each year. These soap bars are often thrown away after just a few uses. But soap doesn't just disappear easily, it lasts for months in the environment, creating a burden on landfills and potentially polluting water sources if not properly treated. Meanwhile, in many parts of the world, millions of people lack basic sanitation, and soap becomes a luxury item. Waste and the lack of recycling exacerbate this issue. Recognizing this problem, Clean the World, a nonprofit organization, aims to recycle used soap into new bars of soap to distribute to those without access to it. Since then, this organization has distributed over 50 million bars of soap to 127 countries. Let's explore how used bars of soap are recycled. Everything begins with collection from sources like hotels and restaurants. These soap bars are gathered and sent to recycling factories. Here, the soap is thoroughly cleaned to remove impurities. After being sorted, the soap is fed into a grinder. This machine, equipped with high-speed rotating blades, cuts and grinds the soap bars into small, evenly sized pieces. Once the soap has been ground, it goes through a sterilization process. A common method is using heat. The soap fragments are heated at high temperatures for about an hour to kill bacteria and other pathogens. The soap mixture is compressed into molds under high pressure to form solid soap bars. After pressing, the soap is cooled and hardened before being removed from the mold. From used soap bars, we've created new ones. These products are not only visually appealing, but also as safe and effective as the original bars. Recycling soap isn't just about reducing waste. It's a humanitarian act that helps bring soap to those who need it most. These recycled soap bars are distributed to underprivileged communities, helping to improve sanitation and prevent disease. Today, some hotels are starting to adopt a different approach to minimize waste by completely removing single-use toiletries from their rooms. Instead, they offer bulk products. Clean the World recognizes that this is also a possibility for their hotel partners. The plan will be to create new impact products, such as hygiene kits and corporate event packages, to offset potential declines in production and revenue. Each recycled soap bar tells a story of hope, sharing, and responsibility towards our planet. By recycling soap, we're not just protecting the environment, we're bringing hope to millions of people around the world. Let's join hands to turn each old soap bar into a new opportunity for those who need it, with a simple act of leaving your toiletries in the hotel room instead of taking them home. The journey of an electrical wire doesn't end when it no longer serves its purpose. Within every old wire lies a valuable copper core, ready to be reborn for a new life cycle. Today, we'll explore how these seemingly useless wires are revived to become raw materials for countless new products. Every old electrical wire is like a carefully wrapped gift. On the outside is a thick protective plastic layer, and inside is the precious gift, copper. The first step in the recycling process is removing this outer layer, a task requiring precision, like peeling an apple without damaging the core. These old wires are fed into a shredding machine, where sharp blades spinning at high speed crush them into small pieces. The next task is to separate the copper from the mixture. A pneumatic separator takes on this role by blowing air through the wire scraps in a chamber. The strong airflow blows the lighter plastic or rubber insulation away from the copper, which is heavier and falls to the bottom. But the process isn't over yet. To achieve pure copper, we need another step. The copper is passed through a magnetic separator, which captures metallic impurities while leaving the copper untouched. After this step, we have pure copper ready for the melting process. In the furnace, copper endures temperatures of up to 1200 degrees Celsius, a harsh environment that removes impurities and allows the copper to be reborn in its purest form. The copper melting process takes place in large industrial furnaces where the copper is liquefied. In this high-temperature environment, lighter impurities float to the surface and are removed, ensuring that the final product reaches the required purity. The furnace is the heart of the metal recycling process. It uses gas or electricity to generate the high temperatures needed to melt the copper evenly. This process doesn't happen quickly, but it is sure. Copper needs time to shed its impurities and reach its purest state. After the copper has been refined and purified, the next step is casting. The molten copper is poured into heat-resistant molds, where it quickly cools and hardens into copper ingots. The rolling process begins with hot rolling. Copper ingots are passed through hot rolling mills to thin them down and reduce their size. Hot rolling reduces the thickness of the copper without losing its mechanical properties. The rolling mill consists of two large steel rollers rotating in opposite directions. As the copper ingot is fed between these rollers under extreme pressure, it gradually thins out, much like flattening dough with a rolling pin. This process is called hot rolling because the copper is heated red hot during the process. After hot rolling, the copper is transferred to cold rolling. Cold rolling helps thin the copper sheets to precise thickness and improves the material's hardness. Cold rolling takes place at room temperature and shapes the copper into thinner sheets with exact thickness. This is the final step to prepare the copper for other applications. To turn the copper into wires, a wire drawing machine is used. The machine features a special die with multiple circular holes that gradually decrease in size. The copper ingot is pulled through these holes, similar to threading a string through a needle. With each pull, the copper's diameter shrinks until it reaches the desired size. The rolling and wire drawing process not only prepares the copper for industrial use, but also ensures that the final product is of high quality and precision. After being drawn into wires, the copper wire is dipped into a chemical solution to clean the surface, removing any oxides and impurities. The wire is then dried and finally coiled into spools of various sizes for ease of transportation and use. Recycled copper helps reduce the need for new mining, protecting mining areas and minimizing environmental degradation. According to statistics, the copper recycling process uses 85% less energy than producing copper from new ore. Once the recycling process is complete, copper is no longer raw material, but an essential component for various industries. Thanks to its excellent electrical conductivity, high durability, and malleability, recycled copper is used in numerous applications, from electrical wires and car parts to complex electronic products. If every copper particle could tell a story, it would narrate a thrilling adventure, from being buried deep in the earth to becoming an electrical wire, experiencing aging, and being discarded. But the journey doesn't end there. Copper, like a warrior, never gives up, ready to return from waste to continue serving humanity. Like reforging an old sword to make it sharper and stronger. Recycling copper is not just about reuse. It's a transformation of seemingly useless things into brand new, stronger, shinier materials, ready for a new journey. Copper is one of the few metals that can be recycled indefinitely without losing quality. This makes copper the ageless friend in the world of resources, always ready to be reborn and serve new purposes. While other materials may degrade after several recycling cycles, copper retains all of its physical and chemical properties. This makes copper a valuable resource, not only for today, but for the future as well. No matter how many life cycles it goes through, copper always retains its strength and unlimited ability to serve. Recycling copper from old electrical wires is a clear demonstration of the power of technology and environmental awareness. Every recycled copper wire represents a long journey from waste to becoming a vital part of modern industries. But more importantly, it's a reflection of collective efforts to protect natural resources and reduce the negative impact on our planet. Every old wire you discard isn't just trash, it's an opportunity to regenerate a valuable resource. Let's recycle together for a more sustainable and brighter future. With copper, the life cycle never ends. It just starts anew, stronger, and more resilient. Hello everyone, and welcome to IronHand Tech. Today we're diving into a fascinating and crucial journey in the battle against waste, recycling old fabrics. But before we get into the nitty-gritty of each stage, let's take a quick look at some eye-opening numbers to understand the current situation better. Every year, around 92 million tons of textile waste are dumped into the environment globally. That's equivalent to a truckload of old clothes being discarded every second. And here's the kicker. Most of it will never fully decompose, especially synthetic fabrics like polyester. Those old shirts we forget about could outlive an entire generation. Textile waste doesn't just take up space in landfills, it also significantly contributes to environmental pollution, from contaminating the soil to polluting groundwater and even the air. According to a report by the U.S. Environmental Protection Agency, EPA, an estimated 11.3 million tons of textile waste ended up in landfills in the United States in 2018 alone, making up 7.7% of all municipal solid waste. Meanwhile, a report by the World Bank shows that the textile and fashion industry is responsible for around 20% of global industrial water pollution. The production of new fabrics also consumes a vast amount of resources, such as thousands of liters of water to produce just one cotton shirt, not to mention the energy and chemicals involved. So what is fabric recycling? Simply put, it's the process of turning old, outdated, or damaged clothing into new products, or, at the very least, recycling materials to be used in other industries. Fabric recycling not only helps reduce waste, but also saves resources and minimizes environmental impact. In today's video, we'll go through the entire process, from collecting old clothes, through processing, to transforming them into new products. And most importantly, we'll explore the modern machinery used in each stage and why they're so vital. Get ready to discover a world we rarely see, but one that plays a crucial role in our everyday lives. The first step in the fabric recycling journey is collection. Have you ever wondered where all those old shirts and ripped jeans go when we no longer need them? Don't worry, not all of them end up in the landfill. Old clothes are collected from various sources: households, fashion stores, and charitable organizations. Some people choose to donate their old clothes to those in need, while others drop them into recycling bins scattered throughout cities. There are even regular clothing collection events to encourage people to participate. Once collected, the clothes are sent to sorting facilities. This is a critical step in the recycling process. Here, the clothes are sorted based on material, color, and condition. Fabrics like cotton, polyester, wool, and silk are separated because each type requires a different recycling process. To do this, both modern technology and human labor are used. Optical scanners and sensors are among the key tools that help automatically sort items based on color and material. These scanners can detect and sort thousands of items in just minutes, a task nearly impossible if done manually. However, in many cases, manual sorting is still necessary, especially for complex fabrics or items with multiple layers of different materials. Why is such detailed sorting necessary? Because each type of fabric undergoes a different recycling process, and accurate sorting optimizes this process. If a polyester shirt is mixed with a pile of cotton, the recycling process will face difficulties, leading to lower quality or even unusable final products. Sorting is not just a preparatory step, it's a decisive factor in the success of the entire recycling process. After sorting, the clothes undergo pre-processing before being recycled. You can imagine that old clothes aren't always clean and ready to be recycled immediately. They need to be cleaned and have any unwanted parts removed. The first step is cleaning. This isn't as simple as doing laundry at home. It's a complex industrial process. Industrial washing machines are designed to handle large volumes of clothing at once, using strong water pressure and specialized detergents to remove dirt, grease, and other contaminants. Some modern technologies even use biological enzymes to break down organic stains, making the cleaning process more efficient without needing excessive chemicals. Next is the removal of unwanted components like buttons, zippers, and other metal accessories. This step is crucial because if these parts remain during recycling, they could damage the machinery or reduce the quality of the final product. After pre-processing, the old fabric is ready for the fiber processing stage. This is where your old clothes start to transform into new materials. The first step is shredding. The old fabric is fed into an industrial shredder where it's torn into small fibers. This shredder is like a giant metal monster with sharp blades spinning at high speeds, tearing everything into fibers. These fibers are then separated by material using a fiber separator, which helps accurately classify the fibers so they can be easily recycled into new products. The fiber separator is one of the essential tools in this process. It helps separate different types of fibers without damaging their structure. This process requires high precision and speed because time is a critical factor in industrial production. Once separated, the recycled fibers are moved to the next stage of fiber processing. Here, the small fibers are combined to create new threads through a spinning machine. This machine is similar to a weaving machine, but with much greater capacity, capable of spinning thousands of meters of thread in an hour. This process requires a perfect balance between speed and durability, as if the fibers are spun too quickly, they'll break, but if too slowly, the process won't be efficient. Spinning machines are designed to ensure that each thread produced is of consistent quality and strong enough to be used in new products. However, processing recycled fibers isn't always straightforward. Some fibers, like polyester, need to be melted before they can be spun into new threads. The melting machine operates at very high temperatures, liquefying the polyester fibers before molding them into new threads. After being processed into new threads, we move on to the weaving stage. This is where the recycled threads are turned into new fabric sheets, ready for various applications. The industrial weaving machine is the heart of this stage. With modern weaving machines, thousands of threads are connected and woven into large sheets of fabric in just a few hours. These machines can weave at incredible speeds, but without sacrificing precision. Every thread, every stitch is carefully calculated to ensure the final product's quality. Once the fabric sheet is woven, it goes through the finishing stage. This stage includes several smaller steps, from cutting, sewing, dyeing, to the final quality check. Automatic cutting machines help cut the fabric into smaller pieces, ready for the sewing or further processing steps. Dyeing is also an essential process. The dyeing machine uses special dyes to create fabrics with bright and durable colors. This not only makes the recycled fabric more attractive, but also makes it suitable for various applications, from fashion to industry. So after all these complex steps, what can recycled fabric be used for? The answer is a lot of things. Recycled fabric can be used to produce new clothing, textile products, carpets, insulation materials, and even in construction. With each sheet of recycled fabric, we not only reduce waste, but also save resources and energy compared to producing new fabric from raw materials. Moreover, with technological advancements, recycling old fabric is becoming more efficient and environmentally friendly. Research is focusing on developing enzymes and bacteria that can quickly and safely decompose fabric, opening the door to new recycling methods. The future of fabric recycling is bright. With efforts from scientists, engineers, and even consumers, we can hope for a world where old clothes are no longer a burden on the environment, but a valuable resource that drives a circular economy and protects our green planet. Think back to the last time you threw away a pair of slippers. Do you remember what they looked like? You might find them in today's video. We're at a local recycling plant. There are a lot of old shoes being collected here, all ready for the recycling process. First, these slippers are crushed into small particles to create raw materials for the recycling process. Most slippers are usually made of plastic, so they can be completely recycled to create new products. Did you know that every year an estimated 20 billion pairs of shoes are produced worldwide, of which sandals make up a large portion? However, due to their short life cycle and rapidly changing fashion trends, a large number of sandals are discarded after a short period of use. The amount of sandals discarded each year could be enough to cover an area as large as the Amazon rainforest. They are one of the most common types of plastic waste globally. The plastic pellets are bagged and transported to another area where they are recycled again. The plastic pellets are fed into a melter where heating elements melt the plastic pellets to the appropriate temperature of up to 300 degrees Celsius. We have a lot of shoe uppers here, which are part of this recycling process. These shoe uppers are fixed into molds before being molded into the soles. The molds are made of steel to withstand the high temperatures and pressures during the molding process. The molten plastic pellets are transferred to the injection chamber by a screw. This screw rotates and moves forward, pushing the liquid plastic towards the mold. The liquid plastic is injected into the mold with the shape of the shoe sole through a nozzle. The liquid plastic is injected into the mold with high pressure to ensure that the plastic fills the entire mold cavity, creating the exact shape of the shoe sole. After cooling, we have a finished pair of shoes. The final job is to cut off the excess plastic, add the inner sole, package, and send these shoes to the place of consumption. You see, your discarded slippers have now been reborn as a new pair of shoes. PET, short for polyethylene terephthalate, is a thermoplastic polymer in the polyester family. It is one of the most common plastics in the world and is widely used in the food and beverage industry due to its transparency and ability to preserve liquids for a long time. You can see millions of plastic bottles coming to this factory. Here they are sorted by type and color and ready for the recycling process. The plastic bottles are fed into a crusher by conveyor belt to be crushed into small pieces. At this point, we have a mixture of PET plastic pieces and impurities such as corks and packaging. Interestingly, recycling plastic bottles also reduces water consumption, as new bottles require 6 times the amount of water to produce. The mixture then passes through a large tank where the lighter bottle caps and packaging float to the top, while the heavier PET plastic sinks to the bottom. This is the most common way to remove impurities and recover PET plastic. Since the cleaned PET flakes contain water, they need to be dried using a dryer. At this point, we have plastic flakes that are eligible for recycling. After packaging, to achieve the desired output quality, these plastic flakes are mixed with additives, colorants, and ground into powder to serve the next process. This is the plastic pelletizing machine. When the molten plastic filaments come out of the mold, they are passed through the pelletizing cutter. The cutter in the machine will rotate and cut these plastic filaments into short pieces of uniform length, usually 2 4mm forming plastic pellets. PET plastic is fed into the extruder. Here, at a temperature of 240 degrees C to 280 degrees C, the plastic pellets are melted in the cylinder thanks to the heating belts located around the cylinder and the friction when the screw rotates. The screw moves the material from one end of the machine to the other, while creating pressure and friction to melt the plastic pellets. Extrude them through a mold. The mold has a structure similar to the shape of the water pipe we want to create, and as the plastic flows through, it will take the shape of the mold. After being extruded through the mold, the hot plastic pipe will be cooled quickly. The cooling process helps ensure the durability and quality of the water pipe, helping them withstand great pressure and be durable over time. The plastic pipe is then cut into lengths suitable for use requirements. And this is the product of this process, large-sized water pipes ready to be used. Isn't it interesting? Now let's move on to a new factory, where old cardboard boxes are given a new life. Cardboard boxes are considered an environmentally friendly product. However, they are made from wood harvested from industrial tree-growing areas, and like many other materials, they need to be processed after use. After being sorted, the cardboard boxes are fed into a shredder, basically a giant blender. Here they are chewed up by blades. The fibers in the paper are broken down in the process and become suspended in water to form a slurry. After being crushed, they are fed into a filtering system to remove impurities. This system includes a screening system, a centrifugal filter system. As a result, we have pulp that is eligible for recycling. At the forming machine, the cleaned pulp is spread out to dry on a flat conveyor belt in a hot cylindrical surface. As the pulp dries, the excess water is also pressed out. This process effectively forms long rolls of solid sheets from the fibers. These sheets are pressed through rollers. At this point, the thickness of the paper is determined, which will be between 100 and 210 GSM. This process produces large rolls of brown paper with a width of 2.5 mm, which can weigh up to 10 tons. These sheets will be used to produce many other useful products, such as paper boxes, toilet paper, tissue paper, helping us save resources and protect the environment. In this factory, we can see a lot of old car bumpers. What will they be recycled into? Let's find out right away. First, of course, these bumpers are cut into short pieces for the convenience of the crushing process. You can see thousands of old bumpers in this factory. After being cut short, they are put into the crushing machine. Look at these men. What are their lungs made of? What extraordinary strength can help them work in this environment? Car bumpers are usually made from PVC, which is a durable, corrosion-resistant, and easy-to-work plastic. The crush bumpers are fed into a mixer, where they are mixed with heat stabilizers, antioxidants, and possibly hardeners. The pieces are then fed into a furnace, where they are melted. Can you smell the plastic when you watch this scene? The melted plastic is extruded through a screen. Immediately, they go to the granulator. In the granulator, the melted plastic is extruded into long fibers. They are cooled immediately and fed into the cutting machine. The blades rotate evenly and cut them into small particles. These small plastic pellets are now ready for the final stage. The pellets are fed into the extruder, where they are melted again, and after passing through the screw, they are pushed into a tubular die. They now have the desired shape of the pipe. The finished pipe is cooled immediately to harden and rolled into large rolls, ready for use. Great, we have just discovered together the top 3 interesting recycling processes that you cannot expect. Let us know what you think about this video in the comment section below. If you want us to make a video about any process, let us know, and don't forget to subscribe to the channel so you don't miss other interesting videos. Now goodbye, and see you in the next videos.